back, and today we are talking about metals, nonmetals, and metalloids. But first, let's take a look at the periodic table. So remember, we looked at the periodic table when we were talking about atoms. So now let's see how it's divided and how it's categorized based on metals, nonmetals, and metalloids. So as you can see, it's color-coded for you, and you can see the different areas of where the metals are located, the nonmetals, and the metalloids. So you'll probably notice that the metals take up most of the periodic table. So most of the elements are classified as metals. So if you look a bit closer, you probably notice things like gold, silver, aluminum, all metals in that area. That is on the left side of the periodic table. Now if we go to the other side, the opposite side, the right side, you'll see the nonmetals. Nonmetals are usually gases, so you probably noticed hydrogen, oxygen, carbon, helium, yes. And then in the middle, you'll see the metalloids. So the metalloids are in the middle, and we're going to explore a little bit about why. And those are located on the staircase. So I brought a few examples of some of the elements with me today so you could see some of their properties. Let's start with one I know that you've seen before. Yes, this is a piece of foil. Everyday item I know you've seen, probably used. And what are some properties about this? It's shiny. It can change shapes, right? We can wrap it around whatever kind of container we have. And it's pretty durable. And we can't really break it. We can tear it because it's a thin sheet. But the great thing about metals is that they are malleable. Can you say that with me? Malleable. So that just means that we can change their shapes and they wouldn't break. So like metal, we can make it into sheets, we can make it into wire, or something else you've seen before, coins or change. So if I took a hammer and tried to hammer these pieces of this quarter and this penny, it probably wouldn't break. Let's try. Safety first. Not at all. So they might have dented a bit, but they're not going to change shape or they're not going to break. So they're malleable. And they're also pretty strong, so we also call that ductile. Think about duct tape, how strong duct tape is. So those are metals. And also, if you notice, metals are usually solid at room temperature. Okay, another property of metals is what we call conductors. That means that they can conduct electricity or allow electricity to flow through. So I brought with me an energy ball. This is like a little mini circuit, and if you connect these two metal pieces, then the circuit will be complete and something will happen. So let's see. We're gonna try our foil first, and I'm just going to connect one side to the other. So it's lighting up and it's making the noise. So that's what we call a good conductor. If we also use our coins, our other metal, we can also test it out. Doesn't quite reach, so I'm gonna use both. So they both conduct electricity well also. So metals are good conductors. They do allow electricity to flow through. Okay, next we're gonna skip over to the other side of the periodic table and talk about nonmetals. So what are some nonmetals that you recall seeing on the periodic table? Right, most are gases. So whenever you think about nonmetals, you're probably thinking about gases at room temperature, just like this gas that I use to blow up this balloon, or gases like helium we use to also blow up balloons, but all the air around us. So nonmetals are usually gas at room temperature. All right, I do have another example of a nonmetal. So here I have sulfur. So sulfur, as you can see, is dull. So you can also probably see in the picture a little bit better. It's kind of like a powder-like, or can be, because it's so brittle or it breaks easily. Can you say that word brittle with me? brittle. So that just means that it breaks easily. So I have a little bit right here and we can see safety first. If I use the hammer again, what's gonna happen? So you can probably see here that it basically turned to a powdery substance. That's because nonmetals are brittle or break easily. I also brought with me another piece of nonmetal that I know you've seen before. Yep, you guessed it, charcoal. Charcoal is made up of mostly carbon. So if I use my energy ball again and I test out charcoal, let's see what happens. Nothing. That's because nonmetals are good insulators or poor conductors. Can you say that word insulators with me? Insulators. Good job. That just means that they do not allow electricity to flow through. Hence why our energy ball didn't work. So I brought something else with me that you probably will recognize. Yes, so graphite, or the lead of pencils, is also made up of carbon. So you probably have noticed whenever you have a piece of lead, it breaks easily. It's brittle. And now if we try our carbon with our charcoal, try to break that with our hammer. Let's see. Safety first. All right. That was a little bit tougher than our sulfur, but as you can see, it did break down and some of it did turn into a chalky substance. So charcoal or carbon is also brittle. Okay, now let's talk about our metalloids. So our metalloids are in the middle, in between our metals and our nonmetals. And that's because they take some of the properties of both. So depending on the element, they can act more like a metal or more like a nonmetal. But I think one of the biggest things that you'll notice is that they are semiconductors. Let's see, what does that mean? Are they going to conduct electricity? Yes, they do. So our metalloids are semiconductors. Can you say that with me? Semiconductors. Exactly. So they do conduct electricity. They're just not as great conductors as metals, and they're not insulators like nonmetals. But you can see our silicon is shiny like a metal. Let's see if it's as brittle. Safety first. So you can probably see this here. It did break pretty easily. So it is brittle. So it has properties, again, of both metals and nonmetals. That's why they're in the middle, that staircase, because they're kind of in between. They are called metalloids. So the main property of metalloids are being semiconductors. So remember, our metals take up most of the periodic table, and that's on the left side. Remember, they are solid at room temperature. They are great or good conductors. They are malleable and ductile. We can change their shape. So if we take a look on the other side of the periodic table, the nonmetals, then we know that they are mostly gas at room temperature, but they can be solid. They're going to be dull, not shiny like our metals, and they're poor conductors, or what we call insulators. They're also brittle, which means they break easily, as we saw with our sulfur. So then if we look in the middle, the zigzag or the staircase, as I like to call it, then you'll find your metalloids. Remember, they are in between because they act similar to metals and nonmetals, depending on the element. As we saw with silicon, it was shiny, but it was brittle, and most of all, they are semiconductors. So now it's your turn. Find a couple of items you have lying around and try to classify them using the properties we went over today as either a metal, nonmetal, or metalloid. If you're not sure what something is made of, do a little research and try to find out. Thank you for watching, and we'll see you next time.